Okay, so we're going to continue looking at the laws of logarithms today. We've already developed them and seen how we can determine equivalent forms using these laws. And so we'll just do some more practice with that today. So remember that we had our three laws we looked at last week. So on page 39, they're written there. Log base c of a times b is equal to log base c of a plus log base c of b. Remember that the laws of logs are connected to the laws of exponents. When you're multiplying powers with the same base, you add the exponents and keep the base the same. Well, if you have the product of a log or the log of a product, you can take the individual logs, add them together, and keep the base the same. The quotient law says that log base c of a divided by b is log base c of a take away log base c of b. And the power law of logs says the log of a power can be written with the exponent in front as a coefficient. That's the power law. And these laws work in both directions. You can go from the left side to the right side, or you can go from the right side to the left side in each case. So on page 40, we're asked to write each expression in terms of individual logarithms x, y, and z. So when you use these laws, the bases stay the same. These will all be logs with a base of 5. And because on top the x and y are multiplied together, that's the product law. That'll be log base 5 of x plus log base 5 of y. And then because it's divided by z, that's the quotient law. So you have minus log base 5 of z. So that's what we're asked to do. Write them in terms of individual logarithms, x, y, and z. Question B. The cube root of x can be written as a power, x to the 1/3. And then the exponent can come in front as a coefficient. So it'll be 1/3 log base 7 of x. Question C. 1 over x squared can be written as x to the negative 2. So this will be log base 6 of x to the negative 2. And then again, the exponent comes in front as a coefficient. With question D, because you've got two factors on the bottom that are multiplied together, my first step would be to write like this. We have log of x cubed minus, because those two on the bottom are a quotient, a denominator, but inside brackets here, you've got y times the root of z, which is log of y plus log of z to the 1/2. Because square root means power a half. And the coefficients can come in front as, the powers can come in front as coefficients, the exponents. So that's 3 log x, and if I remove the brackets, I'll have minus log y minus 1/2 log z. Right, same thing on the next page. For the first one, because it's x divided by y, that's the quotient law. Remember, the bases stay the same. So it's log base 6 of x, take away log base 6 of y. Now for question B, that's log base 5 of x times y in brackets because the xy is under the radical. The xy have to be in brackets, both to the power a half. So this would be the same thing as log base 5 of x to the 1/2 times y to the 1/2. And now we can use the product law to break these up. It'll be log base 5 of x to the 1/2 plus log base 5 of y to the 1/2. And then finally we can use the power law to bring the coefficients out front. So now we've written in terms of log x and log y. Question C, I have log base 3 of 9 over, now I'll write that cube root of x squared as a power. It'll be x to the power 2/3. I can bring that x to the 2/3 from the bottom to the top. So it'll be log base 3 of 9x to the negative 2/3. And so on top, we've got the product of 9 and x to the negative 2/3. So we can break those up using the product law. That'll be log base 3 of 9 plus log base 3 of x to the negative 2/3. And log base 3 of 9 would be 2. That's asking 3 to what power is 9. And then to finish us off, we'll use the power law. The negative 2/3 comes in front as a coefficient. So it'll be 2 take away 2/3 log base 3 of x. Question D. These will all be written as log base 7. Excuse me, we have a presentation to make, so
okay.
I'll need a picture and that's okay, just put it on my desk. Thank you.
I signed in at the office.
Okay. Are you off the band?
Yeah.
Okay.
We have a concert on not this Tuesday, next Tuesday.
Okay. So the 5 can come in front as a coefficient. And the root of z could be written as z to the 1/2. And so our last step will then be to bring that 1/2 in front as a coefficient as well. So we've written those in terms of logarithms of x, y, and z. So as we saw last week, we can use the laws of logs to simplify, to express as a single log. And in many cases, once you've done that, it makes it much easier to evaluate. Right now, we can't really evaluate any of these terms without using our calculator. But let's see what happens when we use the laws of logs to combine these into one single term. Because it's log base 6 of 8 plus log base 6 of 9, that'll be log base 6 of 8 times 9. And then because you're subtracting log base 6 of 2, we'll have a denominator of 2 there. So 2 goes into 8 4 times, and 4 times 9 is 36. So this will be log base 6 of 36, which this is asking 6 to what power is 36? The answer is 2. So by writing it as a single log first, we don't even have to touch the calculator. You could certainly use your calculator to check it though. If you have the newer operating system with the log function built in, log base 6 of 8, which would be an irrational number if you evaluated that on its own, but we're going to finish this off. Log base 6 of 9. Whoops. Try that again. Log base 6 of 8 plus log base 6 of 9. Minus log base 6 of 2. Okay, so it works. And remember, if you don't have this function on your calculator, you can still do it by using the change of base identity. Log base 6 of 8. I'm going to open up a bracket here. Using the change of base identity, you can use whatever base you want as long as you keep the bases the same. And your calculator is programmed to evaluate common logs base 10. So we write these both with base 10. It'll be log of 8 open a bracket, log of 8, close the bracket on the 8, so it just takes the log of 8, divided by log of 6, close the bracket on the 6, and then close the bracket that we opened at the start to keep those two terms together. Plus, log base 6 of 9, using the change of base identity, would be log of 9, close the bracket on the log of 9, divided by log of 6, close the bracket on the log of 6 and on that term, minus log base 6 of 2 would be log of 2 divided by log of 6. Close the bracket on the log of 6 and on that term. You get the same answer. So if you don't have the newer operating system with the log function, use the change of base identity to check. Question B. I would start by breaking this up using the laws of log. Because it's 7 times the root of 7, it'll be log base 7 of 7 plus log base 7 of 7 to the 1/2. Square root means power 1/2. And log base 7 of 7 is 1 plus 1/2 log base 7 of 7. So the exponent 1/2 comes in front. And Amy, what's log base 7 of 7? Well, he's saying they're number 1, but they weren't because they lost in the final yesterday on the weekend. But yes, why is log base 7 of 7 1? Because this is asking 7 to what power is 7. If you use a change of base, it'd be log 7 over log 7. Dividing something by itself gives you 1. So this would be 1 plus 1/2 times 1, which will be 3/2 or 1.5. Question C. We can use the laws of logs here to write it as a single log. What I would do first, this first part, that first term, is bring the 2 up as an exponent. And inside the brackets, I would do the same thing. I have log base 2 of 6 plus log base 2 of 27 to the power 1/3. Before we combine these two, we have to have them as individual logs, no coefficients. So that first term, 12 squared is 144. And 27 to the 1/3 is the cube root of 27, which is 3. And now, because I've got those two terms inside the brackets expressed as individual logs, and because those two logs are added together, I can use the product law to combine them. It'll be log base 2 of 6 times 3, or log base 2 of 18. So again, I haven't even had to touch my calculator yet. And now, because I'm subtracting two logs with the same base, I can use the quotient law to combine them into a single log. It'll be log base 2 of 144 over 18. So now I might need the calculator to do that part. And you get 8 as the answer. And log base 2 of 8 is 3. That's asking 2 to what power is 8. Right, but you can use the calculator to evaluate that, whether you use the log function if you have it, or use the change of base identity to divide log 8 by log 2. So again, we want to simplify and evaluate. Sometimes it means you are combining terms, sometimes it means you're expanding terms. Right? You just want to get them to a place where you don't even have to touch your calculator. And because in this case, the 9 and the root 3 are multiplied together, we can use the product law to expand these. It'll be log base 3 of 9 plus log base 3 of root 3. Log base 3 of 9 is 2. That's asking 2 to what power? 3 to what power is 9? And the root 3 can be written as 3 to the half. And then the half can come in front as a coefficient. And log base 3 of 3 is 1. So it's 2 plus a half times 1, which will be 2.5. Is it gone? Okay, so we can write that as 2.5 or 5 halves. So for this one, we can't evaluate those ones individually without the use of a calculator, and if we did, they'd be irrational numbers anyways. So let's use the laws of logarithms to see if we can combine them into one log. And like we saw before, because you got those two subtraction ones, I would probably use brackets in front of those last two terms, which will change all the signs inside. If you remove the bracket with the negative sign in front, you'll get what you started with. So we know that what we've done so far is correct. And because we changed those terms inside the bracket to both positive, we can use the product law to combine them into one. And 4 times 2 is 8. And now we can use the quotient law to combine these two into one expression. And I think 1,000 divided by 8 is 125. So this will be log base 5 of 125, which is 3. That's asking 5 to what power is 125? For question C, I would probably rearrange those last two terms. But as I'm doing that, I'm going to use the power law for that first term. And the same thing with the last term, minus log base 3 of 64 to the 1/2. So I'll have log base 3 of 36 plus log base 3 of 2 minus log base 3 of 8, because power 1/2 means square root, and the root of 64 is 8. So now I can combine all three of these using the product and the quotient law. And the 8 in the bottom goes into 36. No, it doesn't. But this gives me 72 over 8, which is 9. Log base 3 of 9. Yep. Why can't you simplify it with the exponents? What do you mean? Well, what else would you do? Well, I guess you could. So you're saying you would have the log base 3 of 6 squared times 2 divided by 64 to the 1/2, but it's not going to change our answer. Yep. And again, by doing it this way, you don't even have to touch a calculator. You're going to do exactly the same thing, just in a different order. So log base 3 of 9 is 2, because log base 3 of 9 is asking 3 to what power is 9. Right, so sometimes you're going to expand in order to do it. Sometimes you're going to combine in order to simplify. You with this, Lane? So for question A, that last term, log base 7 of x is multiplied by 5 and divided by 2. So we can write that 5/2 as a coefficient if we want, which allows us then to use the power law of logs to bring that coefficient up as an exponent, which is something that needs to be done before you can use the laws of logs to combine. So the coefficient of 5/2 comes up as an exponent. And now we can use the appropriate laws to combine. So on top, you're going to have x squared times x over x to the 5/2. So it's x cubed on top over x to the 5/2 on the bottom. And when we divide powers, we subtract the exponents. Excuse me. So to subtract those, I need a common denominator. I would write 3 as 6/2. 6/2 divided by 5/2 is 1/2. Now this also says state restrictions on the variable. Okay, if you write the 1/2 in front as a coefficient, that's fine too. It doesn't need to be, but that's fine. But the restrictions on the variable. So to do that, you have to look at the original expression, and in all the terms, it's the log of either x squared or the log of x. And remember that we have a restriction on the domain that you cannot take the log of a negative number. So our restriction here would be that x has to be greater than 0. You can't take the log of a negative number. You also can't take the log of 0, right? And the reason for that, if you have log of 0 and you want to know what that equals, this is a common log, base 10. This is saying 10 to the power x equals 0. 10 to what power equals 0? Well, there is no answer. Even if x is negative, 10 to the negative 2 is 1 over 10 squared, or 1 over 100. As x gets smaller and smaller, 10 to the x will get smaller, but it'll always be positive. It'll always be greater than 0. So this just shows why you cannot take the log of 0, nor can you take the log of a negative number. So when we're talking about restrictions, that's what we're looking for. Now, we're going to see in this next one, it's not always greater than 0 as the restrictions. But before we get there, we're going to simplify this. So this will be log base 5 of 2x minus 2 divided by x squared plus 2x take away 3. So we can combine those two together using the appropriate law. Because we're subtracting the logs, that's the quotient law. And this can be simplified by factoring. On top, there's a common factor of 2. On the bottom, if we factor x squared plus 2x minus 3, it'll be x plus 3, x minus 1, and then the x minus 1s will cancel. So our simplified expression is log base 5 of 2 over x plus 3. So we have written that expression as a single log in simplest form. Now, what about the restrictions? So to look at the restrictions, you have to look at each term separately, the first term and the second term, or when we combine them, the numerator and the denominator, and we need to figure out what values or what restrictions are there on x so that any of those parts, the top or the bottom, make sure any of those parts are always greater than 0. And so for this top part, where you have x minus 1, and it's just easier to use the factored form to figure out what the restrictions are, instead of going back to the original form before we factored. If you look at the factored form and you say to yourself, well, what values of x will make that x minus 1 equal 0? And the answer to that question is 1. If x equals 1, the numerator will equal 0. But we know that we cannot take the log of 0 or a negative number, so therefore the restriction to that part would be x must be greater than 1. And then on the bottom, you've got two factors. You've got x plus 3, so just for that part, x would have to be greater than negative 3, and then you also have a factor of x minus 1, so for that part, x has to be greater than 1 as well. And now you want to pick the restriction that satisfies all of them. And that is that x must be greater than 1. All numbers greater than 1 are also greater than negative 3. However, all numbers greater than negative 3 are not greater than 1. You need to pick the restriction that satisfies all of them. So there's your restrictions. On the next page, same type, write them as a single log in simplest form and also state restrictions. So we can start here by simplifying inside the bracket. Because you're adding logs with the same base, we would use the product law. But before we do that even, we have to take care of that coefficient in front of the second term inside the bracket by using the power law. The coefficient of 5 comes up as an exponent. And now we can combine those two terms inside the bracket. Because you're adding the logs, you would multiply the arguments. The argument, remember, is what you're taking the log of. So x times x to the fifth would be x to the sixth. Now, before we can use our final law, the quotient law at the end, we have to get rid of the coefficients on both of these terms. So the 4 comes up as a power, as does the half. And 6 times a half will be 3. Whoops, that's x. X to the 3. And now we're subtracting logs with the same base, so we can use the quotient law. So it'll be log base 3 of x to the fourth over x cubed, which is log base 3 of x. And because in each case you're taking the log of x, in all three of the terms you're taking the log of x, our restriction would be that x must be greater than 0. Question B, we can combine those two by using the quotient law. And then, like we did on the previous page, we can simplify this by factoring. X squared minus 9 would be x plus 3, x minus 3. That's a difference of squares. On the bottom, that triangle can be factored to x minus 3, x plus 2. And then the x minus 3's cancel. So this simplifies our expression log base 2 of x plus 3 over x plus 2. So, like we did before, we have to look at the restrictions to each of the factors on both the top and the bottom. The first factor on top is x plus 3. Just from that factor, x has to be greater than negative 3. For the second factor, x minus 3, x has to be greater than positive 3. That's the same thing on the bottom. And then x plus 2 has to be greater than 0, so x is greater than negative 2. And you have to pick the restriction that satisfies all of them, which would be x must be greater than 3. All numbers greater than 3 are also greater than negative 2 and negative 3. So it says describe the transformation or mations that need to be applied to the graph of y equals log base 3 of x to result in the graphs of the following. So we have to think back to what we learned about transformations. But first we need to get these into a form that we can actually talk about the transformations of y equals log base 3 of x. So because the first one is a quotient, 243 divided by x, we can use the quotient law to expand. And the quotient law involves the difference between the two logs. And log base 3 of 243, well, that's asking 3 to what power is 243. I think the answer is 5, but let's check it by using our log function. Log base 3 of 243. Yes, that is 5. So this becomes 5 minus log base 3 of x, or negative log base 3 of x plus 5. And we write it like that because that's the format we're used to using when we're talking about transformations. We want to know what are the transformations on log base 3 of x to get this new one. Well, a negative sign in front means a reflection over the x-axis. And the plus 5 at the end means it's also going to be shifted 5 up. There's been questions like these on diploma exams in the past. So for question B, we'll do something similar. We'll break up the 9x squared. It's 9 times x squared. So using the product law, it'll be log base 3 of 9 plus log base 3 of x squared. Log base 3 of 9 is 2 because it's asking 3 to what power is 9. And for the log base 3 of x squared, the 2 can come in front as a coefficient. And so this can be rewritten as 2 log base 3 of x plus 2. So we want to know what transformations on log base 3 of x are occurring. Well, the 2 in front means you're going to have a vertical stretch by 2. And the plus 2 on the end again means it's going to shift up 2 units. All right, these next ones, there's also been questions like this on diploma exams before. If log of 2 is a and log of 7 is b, then write an algebraic expression in terms of a and b for each of the following. So you have to first write them in terms of either log of 2 or log of 7, which you can do for this first one by using the quotient law. Because the 2 and the 7 are divided, that's the quotient law. That can be written as log 2 minus log 7. Remember, you can write them as individual logs with the same base. And we're told that log of 2 is a, as well log 7 is b. So in terms of a and b, that expression is a minus b. Question B, because it's 7 times root 2, we can use the product law to break it up into 2 separate logs. So you've already got the log of 7, which is b, but now we've got to do something to that second term so we can get it in terms of just log 2. And we can do that by remembering that the root of 2 is the same as 2 to the 1/2. And then that 1/2 can come in front as a coefficient. And because a is equal to log 2, this will become b plus 1/2 a. So we've written it in terms of a and b. Question C, because we're dividing the 49 and 16, we can use the quotient law to say that that's equal to the difference between those two logs. Now remember, we need to get these in terms of log 2 and log 7, which we can do because 49 is 7 squared. And 16 is 2 to the 4th. The exponents come out in front as coefficients. And because log of 7 is equal to a, that's 2a minus, sorry, that's 2b. Log of 7 is equal to b. Log 2 is equal to a. So now they're written in terms of a and b. So you can work on those questions. Remember that assignment from last class? It's due for marks. I think it's 8.3 assignment in your package. That one is due for marks. I will post the solutions to these ones on Google Classroom so you can check your answers.